Well, welcome everyone. Happy to see you all here for closing the day. Well, in this exciting panel discussion on the future of augmented reality glasses and the pivotal role that see-through display technologies will play in shaping it. So I'm very excited to have here these fantastic panelists. And we will present how see-through display technologies overcome technical challenges to pave the way for the ultimate augmented reality glasses. So now is the time for each of our panelists to present themselves. So we can start with you, Tomas.
Hi everyone, I'm Tomas Sluka. I'm the CEO and co-founder of C-Real. Some of you may know us as Creel. Originally I was a hardcore researcher, but now we are developing a micro display that provides true 3D for fully natural visual experience in AR glasses, ultimately like these. And I hope that this panel will tell a bit more about what is it good for.
Awesome. Thank you, Thomas. I'm Naamah Argaman. I come from Meta. I'm a display architect and tech lead in our AR product organization. I get the privilege of working on our next generation smart glasses and AR products at Meta. So what I'm wearing, and hopefully keep the same form factor or better for the future to come, and deliver products that everyone can wear. Marty.
I'm Marty Banks. I'm a professor of optometry and vision science at UC Berkeley. Most of what I do is study the basic vision properties of the human, but we're also interested in applications like how the visual system fits or doesn't fit with various display technologies.
And I'm Avi Bar-Zeev, and in the program you'll see I'm president of the XR Guild, which has nothing to do with this topic. It's about trying to promote ethics in the field. But what I have done in the past in relation to that is I helped start the Apple Vision Pro project at Apple when it was smaller, helped start the Amazon Echo Frames when it was early on, helped start the HoloLens back in the beginning of that. And if you go way, way back, worked on Second Life, Google Earth, and Disney VR back in the 90s. I've been doing this for 30 plus years.
Exciting. Thank you very much to our panelists. So now I will start with a very simple question, but very basic to understand the basics of this panel. So, and I'll ask you, Martin, what's the main difference, explain very briefly, between pass-through and see-through, so that everybody in this room, we are all on the same page?
Pass-through, you have a camera looking at the world that displays the images in close to real time on the display. In pass-through, you're able to see through the display and actually see directly the real world. So ideally, you'd like the two experiences to be similar, but we'll probably get into some issues that make them dissimilar.
And how about see-through display technology?
See-through is where you see through the display to actually see the real world through the headset.
Exactly. So now with augmented reality, we can see that see-through has been perceived kind of as an evolution, such as Magic Leap or HoloLens. Naamah, with your industry experience, can you tell us if you see pass-through as just one phase? And how about the state of see-through display technologies?
There is a lot of value in pass-through displays because the experience can feel very real because the world and the digital content are projected on the same plane, same experience. But the world is coming to us at light field, like every piece of information coming from different angle, coming from a different intensity. It's a lot more natural for us to see a see-through display, but the challenge is there. The main challenge is how do you put the digital content on the real world and it would still look real? At Meta, we define a test, right? The visual Turing test of us as humans be able to tell if something is real or not real. And we would define that we pass the visual Turing test if we can no longer tell the difference between digital and real-world content, just like in the Turing test of computers, right? In see-through display, we have a huge challenge with occlusion. We cannot put shadows. We cannot put something in front of you that would occlude everything coming from the real world. And that's a huge challenge that I'm curious for the panels to comment on.
No. Avi, you have been in this...
comment about occlusions.
Of course.
I think they're extremely important to human vision. I was at a conference years ago where they're going to present stereoscopic video to an audience of maybe 1,000, something like that. And they put it up, and I knew immediately they had the left and right eyes reversed. But the great majority of the audience didn't notice. And they said, wow, how cool is that? And it was a scene filled with occlusions, just as so happened. And occlusions are so powerful in getting depth ordering that it can literally override even reverse stereo. So I agree that getting occlusions right is extremely important.
Yeah.
And very difficult.
And difficult.
Exactly. Now, Avi, you've been in this space for over 30 years. What's your take on the fact that are we considering pass-through as a phase, and is that see-through the ultimate augmented reality display we're all aiming for?
I don't think it's a phase. I think that different technologies are appropriate for different applications. I think that, as someone said, the control that you get when you have the video pass-through is that you get perfect per pixel control. So if it really matters that you want the shadows to be absolutely perfect and everything is pixel aligned, then that is an appropriate way to do it, but it has its limitations. I wouldn't wear it outside. I wouldn't walk around the street with it. And I don't think it's particularly the right technology for when we get to the all-day wearable glasses. I don't think we want to walk around with visors that make it difficult to see our eyes, and the eyes might have to be recreated on the outside of the glasses just to have a social experience. I think when we get to the all-day wearable glasses, it needs to be transparent. And it's really, I think that's got to be really clear. There's just no other great way to do it. But for other uses, the video see-through the video pass-through gives you some superpowers. You can do things like remove reality. You can occlude things. You can edit the world. You can give somebody supervision. You can give them X-ray vision even better than you could in other ways. You could magnify their vision in ways that you couldn't necessarily do optically as easily. So for many applications, it's going to be very important. And I think for many of the work applications, it's probably the better choice today. And then, my big passion is still the all-day wearable glasses. I still want to have those be something that everybody has access to. Those are almost guaranteed to be optically transparent.
That's a very interesting take, to consider it as a different stance, kind of, as you say, giving you superpowers, giving you another possibility of choice also. Tomas, I mean, as the founder of Serial, what's your take on pass-through technology and see-through?
Well, I agree with Avi that that's not like different steps. It's more like a parallel evolution. Of course, we probably agree on that ultimate image of the perfect AR, which is almost nothing or maximally normal-looking glasses on the eyes with perfect content anywhere you want, with perfect occlusion. And everything real is a certain sacrifice of trade-offs. And I would see the main pressures between the utility which the information provides and the sacrifice on the comfort. The comfort can start with the price, but then the weight and so on. So obviously, that one end is there is a very highly immersive and high-quality content and augmentation, but the sacrifice on price, form factor, and all of this, and social acceptance is very big, but it's kind of starting being balanced to some number of people. And on the other end, the very light glasses that just look like your glasses right now, but provide a smaller utility, but again sufficient to just buy it and use it. And I think now we will see the evolution where these two worlds are slowly converging to a device that is somewhere in between and serves kind of the largest part of the population, right? And I think we will still only see what's the right compromise in the middle.
So what's the right compromise? Balancing all these elements in the fabrication of these augmented reality glasses. Now, it's very interesting because recently Meta released a paper on the North Star of augmented and virtual reality, which is to match the display system to the human visual system. Naamah, what are the key display solutions for ensuring the optimal visual experience?
Oh, wow, that's a question to Marty. Because I can talk about the trade-offs. I can talk about how we're thinking when we build a product into what people will actually buy. But yes, we always have trade-offs. We always compromise because we want to build a system that people will be willing to put on their face. I've seen the best AR systems in the world, and they could be huge, but they're bright, they're very sharp, you can do a lot with it, the field of view is immense. But if people won't buy it, then what's the value of it? So as we tailor a display to the human visual system, we are not yet in a position that we can not make a distinction between the real world and virtual world. I hope that in the future, when the resolution gets to the eye resolution, where the field of view is truly immersive, where the color depth is like the real world, then we won't be able to make the distinction. Until then, we have to make compromises. And I'm curious, Marty, what are your thoughts on how to build a system that is tailored for the human visual system?
Well, that's such a big question. So let's talk about vergence and accommodation. I think most of you know what that is, but when you look at an object in the world and fixate it, that means two things: that you direct your two eyes toward it, you converge your eyes when it's near, you diverge your eyes when it's far, that's vergence. And if you're not as old as I am, you focus your eye, you accommodate, so you create a sharp image of that object at the same time. That's what it means to fixate. In the real world, those two systems work together. We know that there are neural links between the two systems. So when you accommodate, that automatically drives convergence. And when you converge your eyes, that automatically drives accommodation. In the display world, in stereoscopic displays, we typically break that relationship. So what you would want is for the person to remain accommodated to the screen distance while they converge to whatever the content is, whether it's behind the screen or in front of the screen or whatever. That's an issue. It requires the system to not work the way it was designed and normally does work. One of the few benefits of getting older is you can't accommodate anymore, and so you live in that world anyway, where you have a vergence accommodation conflict, and you get used to it. But unfortunately, that doesn't really kick in until you're around 50 or so with the condition we call presbyopia. So that's a big issue, is how you resolve this conflict. We know that when you don't resolve it, it causes discomfort in many people. It causes a loss of quick and accurate visual performance if you're performing a task. And people just don't like it when the conflict is there. So that's one issue. And just while we're on the topic of accommodation, I'm going to say one other thing I think is extremely important and not fully appreciated. In the last few decades, we've seen a rapid expansion of the number of people who are becoming nearsighted or myopic. Currently in the United States, roughly 2/3 of 21-year-olds are clinically myopic. In Southeast Asia, that number is more like 95%. And those numbers were much lower 20 and 30 years ago. Okay. So it's logical that's not due to a change in genetics. That must be something in the environment. I wish I could tell you what the properties are of the environment that cause this epidemic of myopia. We think it has to do with lighting, bright light, such as outdoors, seems to be protective against developing myopia. And distance, such as outdoors again, seems to be protective too. But we're still struggling to really try to understand that. Okay, why do I bring this up? 2 reasons. One, most people think, oh yeah, so I'm myopic, I'm nearsighted, I'll go to the doc and get some specs and then I'm fine. Not the case. As your eye grows to become myopic, it lengthens, and that applies pressure between the back of the eye and the retina, which later in life can cause the retina to detach. So we know your likelihood of having a retinal detachment later in life is much higher if you're a high myope. Same for glaucoma, same for cataract, and some other less common diseases. So it's a problem. We're developing a generation of people who in their 60s and 70s are going to be having eye surgery. Okay, that's number one. It's a really important problem, and we need to understand it so we can do something to decrease the incidence. Secondly, with head-mounted displays, whatever it is, you have the ability to control the light environment and the distance environment being presented to the eye. Make bad choices, you might be causing another generation of increasing myopia. So we really need to understand it better and talk to the display community who are listening, they definitely are, about what to do about this problem. So there's
Very good.
2 things.
Can I react
Very
to that?
interesting thoughts,
Do you mind?
Marty.
Can I react to that?
Oh, sure.
One of the
Naamah.
challenges that we have with the current technology is that we only have one plane of interaction. And Tomas can talk through how to solve that. But with the current see-through technologies, we have one plane of interaction, and we could put it at 3 feet, we can put it at 6 feet, we can put it at 18 feet. But if most of human interaction, for all of you here in the audience, you want to interact with your phone, it's at arm's length. You're talking with a friend or a colleague, it's like at arm's length. Most of our human interactions are actually close. Not super close, but fairly close. And that's put a challenge for us, right? When we design experiences, the apps or all the games or any other of social interaction that we plan to put on the Meta glasses, they will likely be somewhere in our vicinity. It's very difficult for us to put it far away because it feels unnatural.
So are there any solutions
Would you
to
mind
this
if I added
multiple?
just one thing to that? So that's a scientific question. If you create a display and you have people doing some task, and you can look at the distances they tend to fixate, get some statistics on that, and then design your display to put the optical distance of the screen at a good compromise. And you want to think about that in terms of diopters. You guys all know diopters, but maybe everyone here does not. It's the right unit to think about distance. Diopters are the distance inverted, typically the distance in meters inverted. So that's the right way to think about this problem. Anything beyond 4 meters effectively is 0 diopters, so you don't need to worry about it. To your point, things in here, that's where it's really concerning. You need to worry about it.
So thank you for outlining all these challenges. Now, Tomas, what are your thoughts on these challenges, and eventually how can we accommodate to them?
Yeah, well, thanks for the intro to the problem which we are solving at the C-Real. That's also why the name, right? It's all about providing the correct focus cues to the eye and fix exactly the problems which you mentioned right now. In fact, there is also a good experiment. You can just try to see how strong is the effect on your own eyes. You close one eye and you do the exercise of changing focus between one finger, second finger, and farther. You will also notice how strong it is closer. And that's not you mentioned also vergence accommodation conflict, where this wrong focus cues just make you feel unpleasant. But the bigger problem, in my opinion, is that you get a conflict with the reality. First, you get a conflict with the reality you are used to see, and in the see-through, you have a conflict with reality that you see right now. So if you want to have information about, I don't know, what you eat or drink, the warning, you should not have next coffee, you won't be able to read it if it is not in the correct focus distance. So you may see it's a small problem, but if you have a display which kind of doesn't deliver the information, then the display doesn't really work, right? And there is no solution on the market, but there is a lot of effort to bring the solution. We work on one of them. And maybe the second reason is you mentioned people feel kind of unpleasant, but usually don't use the devices today enough long to feel consequences. So first, that unpleasant feeling itself, but maybe you can say, is it possible you could have certain, let's say, longer-term damage if you are really using wrong world, or you are seeing a wrong world. It's a wrong cues. So it's just my naive assumption is that's not correct, right? It's like taking wrong glasses and then using them.
I totally agree. If you think of that circuit where accommodations talk in divergence and divergence is talking to accommodation to try to get themselves straightened out when you fixate a target, we think of those circuits as having a gain on them. If it's a gain of 1, it means it's perfectly calibrated. Okay, what happens when you put on a display or do something different, give the patient new glasses, you change those gains. And it takes several minutes for the gains to really start changing. Well, one of the things I worry about is you're in an experience, you change those gains, now you take the HMD off, and the world is now different to you because you've changed the gains. Now you have to readapt to the structure of the real world. And so that's another concern.
I'll make it even
solved by your device.
I'll make it even more dangerous. In the future, we would probably, if our all-day wearable glasses are our main glasses, we're wearing them for vision correction or whatever, imagine driving with those glasses on. Eventually, it will be safe. Today, I wouldn't do it. But if the display plane is at a meter out, and you're seeing some sort of heads-up display telling you about the car or the way you're supposed to go, your eyes are focused on that while you're paying attention to it, and you may not focus on the person crossing in front of your car. They'd be out of focus, and you're less likely to notice them because they're blurry, or another car or whatever. So it could be literally dangerous in that situation. But even walking down the street, if we were going to try to render the name of a restaurant that's maybe 20 meters down the street, and the display plane was a meter away, you wouldn't be able to see the restaurant and the name at the same time, which is ultimately what you'd want to see. And the way we depict AR out in the world is always that works. That's just correct. So we need to be able to focus the virtual graphics correctly to fit on the real world the way our eyes will focus on the real world.
Absolutely. So we have discussed on the visual aspects for ensuring an optimal experience, but there are also other pillars which are also social and wearable, as Bernard Kess describes it, a leading authority in optics and hardware engineering. Naamah, I would like to ask you, what are the display requirements for a full social acceptance of augmented reality glasses?
My take is that no one here in the audience can tell that there is a display on them.
Okay.
It's not so much about the display as it is about the social acceptability of you being able to walk down the street or here in AWE, and no one will be able to tell whether you're looking at digital content or you're looking at something out there or what is it that you do. This is very difficult. We have light emitted from somewhere in the glasses. It's supposed to go inside your eye, but not go anywhere else. So my first requirement is it for be social acceptable. If Tomas would be wearing glasses, I want to be able to see his eyes when we're talking, right? This is normal human interaction. This is the most important thing.
Of course.
Next, of course, we want to make the display itself. It has to be sharp. It has to be bright. Of course, we want it to be immersive, so it covers the entire field of view of the human population. If you experience the Meta Quest 3, for example, and I've seen plenty of them here at AWE, you'll see that the field of view is quite wide. We're talking about something like 110 degrees. This is a wonderful experience, but very, very difficult to accomplish in socially acceptable glasses. So as we move through the natural evolution of AR technology, we will of course, start this development with smaller field of view, and then go larger and larger as the technology matures. And of course, the display will have to adapt to that and still be bright and sharp. And
So it should be an extension of natural interaction, as you say. Thomas, what would you add to that? What other challenges for social acceptance, could we solve?
Yeah, well, I think that's actually probably the biggest challenge, to make the device enough acceptable to wear for, like me. Some people accept whatever, but in general, it should look more or less as a normal glasses. We have the evidence that normal glasses are okay for majority of population. And I actually like the fact that Apple Vision Pro used the reverse pass-through, and Meta Reality Labs also developed some reverse pass-through, and I guess more and more. We can see some on the floor. That's just the evidence how important was to show the face. It's a huge complication for the hardware, but it's important enough to do it because you can provide even this indirect eye contact, right? But it's also obvious that if you have a direct see-through, or most directions, you don't have even this kind of the knowledge that it is not the real eyes, right? That's strange. Even if it is perfect and it's not a real, it still feels kind of not correct, right? Like a fake. So it's obvious that pass-through makes it normal, but it's very difficult.
Sure, so being able to see the eyes, being able to see the face, so normal human parameters for any type of interaction. Now, Avi, as the president of the XR Guild, I would like also to go through the parameter of social acceptance, which also deals with privacy. I mean, when we're having augmented reality glasses, we're also kind of being recorded, because of course all the sensors that are on the cameras are permitting the experience to happen. What are your thoughts on that?
Yeah, I think if you go back to Google Glass and the things that were probably mistakes that were made in the go-to-market of the Google Glass, I think people focus a lot on the cameras. But I think we have evidence from other companies that it's not the cameras necessarily that people object to, it's the way they're used. And in the case of Glass, it was that it seemed like it was almost like the person wearing the glass had power over other people. There was an unequal power imbalance. And it was also the eye glow. It wasn't just the fact that there were cameras. When the person used it, you could see that they were using it. You didn't know what they were doing. You had to wonder, were they looking up your Facebook page? What were they looking at? Were they ignoring you? It just violated all sorts of social norms that are important. Even though I think we still need more rules about cameras in public and how we take pictures. That's a whole other topic. But with respect to the displays, I think that's absolutely important. The no eye glow rule is pretty critical. The question is going to be, I think, ultimately for privacy, who is in control? If we want this to be successful, let me put it that way first, we want to figure out how to empower everybody equally, to bring up the person who's wearing it, to give them new superpowers, but also to enable the people around them to also have power, so we don't feel that power imbalance. That's what makes us react and want to punch the person that's wearing the glasses. So we have to figure out how to do that more or less equally, but also give people the options of opting out. That's a really important privacy consideration. And so I don't think we're quite good enough on that yet. I would say the little recording light is not enough right now. We're sort of okay with cell phones because it's so obvious when you hold up your cell phone that someone's recording. But it's still, we used to be a society where you would ask permission to take someone's picture. And I think technologically we can figure out ways to deal with this. I mean, I think you could imagine a couple of ways that we can design, especially now that you've all seen generative AI. We could be removing people from these photographs using generative AI to blur them or to remove them unless we have their permission. And if everybody knew that, they'd feel a lot less anxious about being photographed out in public. They'd know that you're only going to actually capture their actual self if you have their permission. Otherwise, you're going to get a randomized facsimile of the person, still as good photo quality. So there are some things we need to look at, how to make these things really work well for people in the privacy domain, and to be respectful and to be socially apt. And one other thing I wanted to say about this issue of the eye gaze that we were talking about before, in studying psychology to understand how this works, there are just so many psychological factors that matter to us. There's the power imbalance. There's this concept in psychology of joint attention. If I go and say that, you all know what I'm pointing at. It's not because my finger pointing is accurate. It's not. Believe me, the eyes are way more accurate than the fingers. But you see what I'm looking at. And so we know from context what we mean when we talk, and we have all these shortcuts. The joint attention signal is a huge part of the social interaction cycle that we need. And the amount of eye contact that we make directly is super important to be having a good social cues. You don't want too much. All these clever algorithms that force your eyes to look at the camera, right? You've seen this from various companies where they will use machine learning to make it so your eyes look at the camera. We don't want that. That's actually too much eye contact. We want it to be natural and appropriate, or else people are going to feel like there's a stalker over there, or somebody creepy, or a psychopath. So we have to get that right.
So that's an interesting thought, how to counterbalance the power that technology gives us versus people that don't have eventually the tech. So a very interesting thought to hold on. Now, let's talk also about wearable comfort in augmented reality glasses. So what are the qualities to integrate for the delivery of augmented reality glasses that can be comfortably worn all day? For example, Thomas, what could you tell us about that?
Well, I think it's more appropriate question for Naamah.
Sure,
They
sure.
really
I'm
have
coming to Naamah.
the studies,
Okay.
but I will still probably partially return to the social acceptance, because we cannot skip one extremely important factor, and that's the eyewear is a part of people's identity, and they define how you look, and people really care. So the glasses ultimately can't be just one design fits all. Certainly not one size fits all. It really looks weird, big ones on small head and so on. You may have a couple of sizes, but people will require different aesthetic shapes. And the technology has to allow to make it cost efficiently. So there needs to be way to have multiple different designs for the taste. Anyway, most people will need also their own prescription correction. So all this needs to fit together.
So an interesting thought to represent also kind of the identities.
Yeah. And then it must be light and small, but I think it's better for Naamah to say
So
how
Naamah,
much.
what's your take on that?
My glasses are 49 gram. This is the Meta Ray-Ban glasses that you can buy off the shelf with my own prescription. So, and it took me a while to get used to it. 49 gram was heavy on my nose. I didn't like it. So of course, if we're looking at any of the pass-through headsets that are today around 100-something gram, it's heavy. It's uncomfortable. I would put that limit at around 50. Maybe people with different face, maybe larger face, could handle a little bit over that. But this is our limit. We have 60 grams, 50 grams. It has to be balanced between the nose and the back of your head, right, where the glasses are sitting. It's quite a limitation when we're trying to...
This is as per today. I mean, it will evolve, of course, over time.
I definitely hope so. But I do see people in the audience here with glasses that I would estimate at like 15, 20 grams. It must be very, I mean, kudos to you. It's very light and easy to wear. This will be very difficult for us to shove all the electronics in it and give that AR experience. Even today, my glasses don't have any display. Even without a display, it's very, very challenging, but this is where we're marching towards much lighter, much better balance, and to Thomas's point, much more fashionable with a lot more colors and shapes and sizes to fit everyone's preferences.
No, absolutely. You know, and I have still for you this burning question, how to make this scalable also, which is one of the most important factors out there.
Yes.
One more thing that doesn't often get talked about, and I'm sure they know about this very well, and that is heat. Right? All electronics in processing and doing any work, the output, you take in the electrons, you output heat, inevitably. And that heat on your face is one of the most uncomfortable things. So you have to be able to dissipate the heat. You have to be able to get it away from the face. But in general, the more work you do, the more heat there's going to be. So you want to do the least amount of work. That's one of the reasons why I think the optical transparency will ultimately win out for all-day wearables. It's just lower power. You're using the natural photons that are coming in and not having to recreate those, capture them, and then re-project them. That's got to take more power in general. But the algorithms also need to be very lightweight. It probably also means that these devices are off a lot of the times. There's a lot of maybe, we'd call it AI today, that's running and figuring out when they need to turn on. But a lot of the time they're off and they only turn on when we need them, so they need to be very contextual as well. That's the good reason for having the sensors on them, to be able to understand when it's appropriate to turn on. But a lot of the times they're not going to be on. They're going to be just normal glasses, and we use them when we need them. And the amount of heat is really variable. If just the easiest way to understand this is, take something like a computer and you plug it into the wall, and it can dissipate something like, I don't know, 800 up to maybe 1,200 watts. Some PCs are even higher, but that's typical. 1,200 watts, that's like a hairdryer. Up to 1,800 watts is a hairdryer. Talk about a phone. A phone might be 10 to 12 watts, right? And when you use that a lot, it gets hot, it gets uncomfortable. The glasses have to be measured in milliwatts to microwatts, right? So each step down is a factor of 100 practically in terms of the amount of power that we can expend comfortably. And that limits a lot of the things that we can do in the glasses.
Back to the comfort, I want to talk a little bit about the eye box. The eye box is where your eyes are compared to where the display is actually showing you content. Now, I walked downstairs at the hallway, and some people showed me a demo with, you really had to look, where is the display? And that's similar to the Google Glass experience. If you bought a Google Glass now, 10 years ago, it would be a white glove service. Someone would come to you and measure all your face and how everything fits together, and they'll design the glasses just for you. There's a lot of friction in that. The Meta Ray-Ban glasses, you walk into LensCrafters, you walk into a Ray-Ban store, you walk into any store on the street, and you pick up your glasses, and it just works. And I think there is a scale between, yes, we want your glasses to be fully customizable, and yes, we want you to be able to walk into a store and it would just magically work. We want to be able for you to go into a dinner party and give your glasses to someone and for them to experience all the AR features very naturally. There is no solution that answers for all of it. This is a very, very difficult challenge for us to optimize for. And of course, we always have to find the best solution for everyone. But the goal is to have it fully customizable and for it to work for everyone.
And when might we expect augmented reality glasses to be widely adopted? Any ideas on that?
Sorry, repeat the question.
When might we expect augmented reality glasses being widely adopted?
Oh, good question. This is not something I can
3 to 5 years.
After
we always say
retire.
3 to 5 years.
Always,
Well,
3 to 5 years.
The morning talk of
every year
Ori was
after.
like 2 years ago. Was this prediction from 10 years ago?
Yeah, but every day,
Can I
every
go back
year.
to the iBox for just a sec? There's one piece of good news that is coming out of the research of Emily Cooper at UC Berkeley. So we know what the iBox is for one eye, and we know what the iBox is for the other eye. What she's shown is that in a binocular visual situation, you can get away with more poor fit of the iBox than you can under monocular. And the reason why is the brain does a smart thing. When the right eye sees something that the left eye doesn't see, because it's vignetted, the left eye's image in that region gets suppressed. You lose stereo, but usually that's in the periphery of the eye where you don't have really good stereo anyway. So that's the one piece of good news about the iBox problem is binocularly it's actually a little easier in some ways than one might think.
I'm going to use that.
Huh?
I'm going to use that.
Okay, Emily Cooper.
I'll give you a slightly more serious answer for the timing of it. I do think a lot of these display challenges are huge, and kudos to everybody who's working on them. But I think that heat thing I mentioned, the only offset for heat is to either do less work and have the glasses do less, or wait for the chip process sizes to come down. So every time you shrink the size of the chip uses less power. That's one of the reasons why the companies that are making their own chips make really efficient chips that don't need fans. And that's super important. So if you want to think about like who can really succeed at this, you need the technology to drive the chip sizes smaller and smaller. But some of that is a function of time. It takes a certain amount of time to get the machines built to make the next smaller size of chips. And so that for many reasons means some of the visions of all the grand things we want to do in all-day wearable glasses is still 5 to 10 years out, just for that reason.
And Avi, once we have these ideal displays, how will you fundamentally change augmented reality experiences? How will we cohabit with those?
How will we say again? Sorry?
How will it fundamentally change augmented reality experiences?
Oh, wow. Look, when the most important use case for XR in general that I have always said now for 30 years is the co-presence case. And we've all gotten in cars or planes to come here. There will become a point in time where we'll be able to meet together and have something that feels as good as face-to-face, but not have to spend all the fuel to get around. There'll be some energy spent, obviously, in the tech itself, but we'll be able to meet virtually. And so you'll be able to meet with anybody anytime. You want somebody to pop into your house, they'll virtually pop into your house, and you'll pop into theirs. You don't have to have VR to do that. That is the future, and that's how we all become closer together and more connected. And there's many ways I think that this tech can bring people together in a way that's more social and more essentially elevating of the human spirit by letting us be ourselves. But that's still a ways away. To be able to do that co-presence solution, you need to be able to capture people really well, portray them, right, as some kind of a persona that looks like them. And one of the benefits of the transparent glasses, the see-through, is that if you put external cameras on, you can just capture those people wearing their glasses. You don't necessarily have to recreate them as avatars in that sense, if you can just capture them well. But that's still a hard problem. How do we volumetrically capture ourselves? We don't have cameras around ourselves all the day, so we have typically one webcam or similar. And so we're going to need to see a future in which we're better at capturing humans in a holistic way, and we're better at rendering them in a way that we can feel these face-to-face conversations happening. But when that day comes, I think that we're going to see big changes in society, that people will feel like they're both more connected and also able to work from anywhere. All the things that we didn't quite have ready in the pandemic to let people actually have a better experience of that.
Thank you. And before ending the panel, actually, I would like to talk about AI and how AI is helping the widespread adoption of augmented reality glasses. Naamah, please.
We already implemented a lot of AI use cases on glasses without display. If you, again, going to talk about the Ray-Ban Meta, but contextual AI on awareness of where you are, what you're doing. I don't want to activate my glasses, but you can today ask, hey, Meta, what am I seeing? And the AI assistant actually goes off and tells me that I'm looking at a lot of people in front of me, probably at a conference. It's actually quite disturbing experience to do it on a stage. But other than that, the AI experience is enabled by cameras, but imagine how it could be even better if you can have a visual experience attached to that. So, and imagine an assistant that knows where you are and what you're doing and give you ideas for, you go down the supermarket aisle and what should I cook for dinner and what did I cook 2 days ago and how many calories are in this thing, or recommend a wine, which is a great use case. I really encourage you to try it. There's AI today in everything we do, and we're going to double down on that to make this experience ubiquitous and easy and natural. We don't have to get to co-presence. We can just talk to an AI assistant.
It's a little less human, but yeah.
Yes, that's true.
Well, I think now we will have some time for questions from the audience. So are there any burning questions, any aspects you would like to ask our experts here? Okay, I don't see any.
One, I see.
Oh, yes. Okay, please, are there any mics for?
We'll have to-
I think that will be,
repeat it,
yes.
but go ahead.
Thank you.
So you're talking about heat distribution. Has there been any look into piezoelectric fans or any
Okay, one second. There's somebody coming. I think it will match.
So has there been any look into solid-state piezoelectric fans, or are we just talking conduction, heat dissipation?
Yeah, I'm not an expert, but my understanding is everything has been looked at. It's a really hard problem. What makes heat dissipation work well is having lots of surface area in order to have the heat radiate out and not into your head, but out. Whoever can figure out how to make glasses where the lenses are radiating the heat instead of somewhere on the frames will be really rich. That's a hard problem. But in general, you want to not have fans. You want to every fan is going to add, even a fairly solid state like piezo is going to either add noise or vibration or something that's undesirable. And so the goal is to keep the power low enough that you don't need to have fans. As soon as you have a big enough machine that needs to have fans, you start having a large volume of space and air volumes that need to get moved around. Not my expertise, but that's what I've learned so far.
Hi, everybody. Oh, it's loud. Great panel. Rodolfo, CEO of Viral Games. We specialize in XR VR. So one question, I love the dream vision, kind of blue sky thinking, but it might take some time. What's your hybrid in terms of timing from what exists today to maybe 2-3 years, where maybe the headset is mostly using the compute power of the cell phone or a smartphone instead of using the compute power of the headset? Almost like a hybrid. I'd love to have a lighter headset. The transparency and darkness, that's not the end of the world, but I can just connect it to my iPhone, and this works really well. So thoughts on that would be interesting. Thanks.
That's an interesting question, given that if you go downstairs, you're able to see AR experiences from XReal, from DigiLens, from countless smaller startups. That's a good point. It's not at scale. It's not at scale yet. But the question is, for you, right? For the developers here, what we're showing from hardware perspective, can you imagine how this thing just becomes smaller, right? We have dedicated silicon. We have dedicated components. Over time, it will become much, much smaller. You asked, like, for the next 2-3 years. I think this is the right range of when we're going to start see scaled, ubiquitous, available to the market glasses. They're not going to answer for all of your asks and wishes in the first generation. I wish they were.
To all of you, thank you for such a great panel. I want to ask about the vergence accommodation conflict, because I think it explains some of the fatigue that I and many others feel, even on high-quality mixed reality devices such as Quest 3 and Vision Pro. With pass-through, and see-through for that matter, is there any research that suggests that even in theory, this conflict can be worked around, where you have this like 2D display that's made stereoscopic, or is this like a very hard limitation that our brains will just have to get adapted to?
Has there been research on that? Not to my knowledge, not the kind of research that we would do that really pins down the problem and studies it properly. So to my knowledge, no. But the problem remains that when you have a screen, that you have to get the photons from that screen to form a sharp image in the retina. Your eye must accommodate to that, must focus it. And when you have a stereo display that has, whether it's real world or pass-through or whatever, that specifies a different distance, then the eyes must converge differently. That's just the fact of the matter. It would be good if the field did more studies on the statistics of that conflict and what kind of statistics lead to the adverse effects. There hasn't been enough work on that really to delineate those statistics. So that it would be good if we knew more about that to quantify it better.
And in general, like I've been calling for more studies at this point. Now that we have all the different variations in some form, we have the Apple Vision Pro with, I think, fixed cameras and fixed display. Vario is showing something with a dynamic camera that can actually autofocus. We have optical pass-through. We have all these approaches. Let's compare and contrast and see which are the most comfortable, which have the lowest nauseation, which cause the least eye strain. These are the studies that should be funded so that we learn what is going to be the best for us, and we double down on the things that are working and maybe stop doing some of the things that are harmful.
Yes, indeed. And don't forget visual performance. When the conflict is present, many people, when you change an object from this distance to that distance, take a minute to kind of focus and converge on that object in a way that doesn't happen in the real world. So I totally agree there should be more work done on it, and always include performance along with comfort.
Mm-hmm.
I'm Peter
Thank
Smith.
you. Okay, let's take that last question for today.
Thank you. Yes, Peter Smith from University of Southampton. Question about the role for eye tracking for AR. Do you see a role for eye tracking so we can specifically use foveal rendering type ideas, track the eye, and that way get much better efficiency?
I'd be happy to do that one. I've been a huge advocate for eye tracking. You know, the HoloLens 2 had eye tracking. HoloLens 1 should have had eye tracking, but it didn't make it. And Apple Vision Pro obviously does have eye tracking. And if you haven't tried it, I think I would encourage you all to try it and feel how magical it is when you have really good eye tracking. But to the point about the AI before, I think that there's a huge difference in quality from an AI that just takes a picture of the whole room and has to guess what you meant when you said something, like, what's that? It could be one of 100 things. When you have eye tracking and AI together, the AI is like another person that can say, well, now I know what you meant because I know what you were looking at. And there are a few companies that are working on that. I think it's going to be probably a requirement for these all-day wearable AR glasses of the future that they do have eye tracking, but it raises a whole bunch more privacy questions that we don't have time to talk about, because the eye gaze data is like mind reading, and we really need to be careful about protecting that data. It's like health data. It's like data that can tell you how people are responding to the world psychologically, emotionally, and it needs to get locked down in a way that the person controls it and no one else has access to it.
I want to add one more thing to that about eye tracking. Eye tracking is very critical. It does give you that mind-reading ability. It does allow all of us for the AI agents around us to be aware of what we're intending to do. But also, one of the main challenges is how do we keep it low power? How do we have a sensor that is always on, always looking at your eyes, but takes zero power? Because we want this to last for all day, right? Between charges, you go to bed, you charge your device. This is a huge challenge for anyone who develops eye tracking technology, and I encourage everyone in the space to help us solve it.
There's a few small companies. One of them I advise, so I won't go too far into it, but they're measuring their power in the milliwatts. So obviously putting cameras on your eyes is going to be expensive, but there are other ways to track the eyes with lower power sensors, and I think that'll become a requirement in the future, as long as it can be made safe.
Exactly, and that's a very interesting thought to finish about a panel. So how much also are we giving to technology in order to be able to power all these new advancements in pass-through and see-through. So thank you so much for being part of this insightful discussion on the future of augmented reality, see-through and pass-through technology. Let's take a moment to applaud our fabulous panelists, and thank you all for being here today.